This video is going to have a look at an explanation as to how we calculate Pythagoras within a 3D shape and complete an example. So when we are calculating Pythagoras in 3D, we are often asked to find a length within the shape that is not form part of the edges. So for example, we've got a rectangular prism and we would be asked to calculate the blue dotted line, so the length of the line from point A to point F. So that's going to be the diagonal between two corners of the rectangular prism. So because we are calculating using Pythagoras, you know that we're going to need a right angle triangle. So you can form a right angle triangle involving the length that you need to help you complete the calculation. So for our example, the right angle triangle would then go from F to C, and then the triangle would be completed by going from C across to A. So that there then forms a right angle triangle that we can use within our calculation. To enable us to use Pythagoras, we will need to know the two sides that form the right angle triangle with the side we are looking for. Often we'll only know one of those sides. So we would probably be given the side F to C, because that is an actual side of the rectangular prism. However, we probably wouldn't be given the side A to C, because that's another diagonal that is being used within the rectangular prism. So because we probably wouldn't know what A to C is, we would also need to calculate A to C. So we can do this by forming another right angle triangle. This time it'll be formed from C to B, then B to A. And that there forms another right angle triangle that we can use and to help us calculate our original distance from A to F. So let's have a look at an example of how we can complete a calculation involving Pythagoras in 3D. So in the example, we've been asked to calculate the length of A to F. So to enable us to calculate that length, we need to form a right angle triangle from F to C, and then back from C to A, the same as what we did in our explanation. So off to the side, I could draw that right angle triangle and start marking in the information. So A, F to C. I'm looking to find A to F, so I'm going to call that A. Now, because F to C is a side of the rectangular prism, and I can identify that as being 5, I'm going to put a 5 in there. And then A to C is another unknown side for the moment, so I'm going to call that Y. So my next step is, before I can find out what that A to F side is, I need to find out my A to C side, the side that I've called Y. So I can do that by forming another right angle triangle. And again, I would draw that off to the side to help me with my calculations. So that triangle can be labeled A, C, B. So I've already labeled A to C side Y, so I'm going to keep that the same. Then I've got C to B, which I can identify as 4 centimeters. And then I've got A to B, which I can identify as 10. So now that I've got one unknown side and two known sides, I can go ahead and use Pythagoras to find a value for Y. So starting out with the formula, C squared equals A squared plus B squared, and then substituting in my known values. So Y squared is going to equal to 10 squared plus 4 squared. So Y will equal to the square root of 10 squared plus 4 squared. So Y is going to equal to 10.77. So now that I know what Y is equal to, I can go back to my original triangle and add that in, which now gives me two known sides that I can use to find my unknown X value using Pythagoras. So again, I'm going to start off with the formula, C squared equals A squared plus B squared, and then substitute in my known values. So X squared is going to equal to 10.77 squared plus 5 squared. So X will equal to the square root of 10.77 squared plus 5 squared. So X will equal to 11.87 centimeters. So by completing the calculations, I've now found my unknown length of A to F, which is equal to 11.87 centimeters. So that's an example of how we can complete Pythagoras within a 3D shape.